In this case, it does give us two pair of angles that are equal. Right, and then it tells us that QT bisects once again, so we can label that information. Right, so in order for us to actually show, let's interpret the bisect, turn it into an equation form. So measure of angle PTQ is equal to the angle of RTQ by definition of bisect. That gives us a pair of angles. Okay, now the QT is a shared side once again, so we can go ahead and introduce that as well. QT is equal to itself by reflexive property. That gives us a pair of sides. So now we have two pair of elements. So we can either choose to find the pair of corresponding sides that would include the given angle, so PT and TR. If we could show that those are equal, we can show congruence of triangles, or any other pair of angles, either pair of angles 1 and 2 or angle pair 5 and 6. Well, even though we can't show either of them or any of those pairs directly, the angles 3 and 4, the information that was provided, is connected to angles 5 and 6. So let's go ahead and see if we can show that those are congruent to each other. The first thing would be to introduce the elements. So we know that 5 and 6 need to be equal, so we have to introduce them into our proof. The way that we would do that is angle 3 plus angle 5 form a linear pair, so they add up to 180 by definition of linear pair. So that at least allows us to introduce the element 5. 6 is the same way. Angle 4 plus angle 6 adds up to 180 because those also are linear pair. I think we now have two things equal to the same thing. So these two expressions are equal to 180, so they must be equal to each other. So we can set them equal. Angle 3 plus angle 5 equals angle 4 plus angle 6. And that's transitive property, or substitution. And then in order for us to get 5 and 6 to be equal to each other, we need to remove angles 3 and 4. Well, we know those are equivalent, so if we remove an angle 3 from one side of the equation, we need to remove the same value or its equivalent from the other. Well, angle 4 is its equivalent, so that allows us to make the new statement, angle 5 has to equal angle 6. And all we did was we subtracted equivalent values, the same value from both sides of an equation. And this leaves us with our third pair of corresponding pieces to be equal to each other or congruent. So now we have two angles, the non-included side, that is a pattern for congruence. So we can make the statement that triangle PQT and triangle RQT are congruent. And the pattern again is two angles, the non-included side, so AAS. Right, so those are the proofs involving congruence of triangles. Okay, were there any questions on those?